Hi, I'm Allison.
And I'm Jeff.
Welcome to the first lecture of Statistics, Making Sense of Data.
The purpose of this lecture is to introduce you to the course and to some of the first data sets that we'll be examining.
This course is an introduction to the science called statistics.
The goal of statistics is to use imperfect information, our data, in order to infer facts, make decisions, and make predictions about the world.
Statistics is the science of collecting, organizing, describing, analyzing, and interpreting data.
It has applications to virtually every area of our lives, from business to health and nutrition, politics and education.
Early in the course, we'll look at descriptive statistics, which is about summarizing data using numbers or plots.
Later on, we'll work towards statistical inference, using data to make conclusions or decisions.
While statistics is a science, we can also talk about a statistic. A statistic is a number or value measured within some particular context. In order to carry out sensible and meaningful statistical procedures, it is important to understand the context.
We need to understand which data were collected, how and why these data were collected, on which individuals or entities the data were collected, what questions we hope to answer from the data, and what group we want to make conclusions about.
One of the data sets we'll look at in the first few lectures is the 2012 salaries of the New York Red Bulls soccer team, which is a team in the MLS, the top North American professional league. MLS players' salaries are released multiple times per year by their players' union. The salaries that teams in the MLS pay their players are governed by some rules, of which 3 are of particular note. Firstly, there is a minimum salary. Secondly, there is the designated player rule. Because of this rule, teams can attract a limited number of international stars, paying them high salaries regardless of the salary cap. And for the third rule, there is that salary cap. That is, there is a maximum total amount a team can spend on player salaries, excluding their designated players. We'll investigate how these rules are reflected in some data, which is the salaries of the 25 New York Red Bulls players in May 2012.
Another source of data for us will be facts and figures for different countries and territories around the world. For example, we will consider the life expectancy for each country, the average number of years a newborn child would live if current mortality patterns were to stay the same. These data were assembled by gapminder.org, using such sources as the United Nations, the Human Mortality Database, the Human Life Table Database, and more. Life expectancy serves as an excellent measure of a country's overall health and well-being. We will investigate how a country's life expectancy is related to various other factors, like which region of the world the country is in, and the country's average wealth, i.e. its GDP per capita, and what fraction of adults in the country are infected with HIV, and so on. Studying these data will allow us to draw statistical conclusions about how different factors influence a country's well-being.
A third data set we'll investigate arises from the problem of estimating the age at death from skeletal remains. This is a common problem in forensic anthropology, and anthropologists have devised several different methods for estimating age. In adults, these methods often rely on examination of the wear and deterioration in certain bones. Developing improvements to these methods is an active area of research. Catherine Merritt, a biological anthropologist at the University of Toronto, is examining how the accuracy of several of the existing methods is associated with physical characteristics, specifically focusing on body size. She has used a number of methods to estimate the age at death of several hundred skeletons of known age so that she can assess the accuracy of the estimated age. We will look at a randomly chosen subset of 400 of the skeletons Catherine has investigated for 2 of these age estimation methods. The first, the method of Degonji et al., uses aspects of the first rib to arrive at the most likely age at death. The second method we will look at later, the Suchy-Brooks method, is the most commonly used method for age estimation and uses the pubic bone. The Suchy-Brooks method classifies the age at death into one of 6 age categories by comparing the pubic bone to reference bones selected as representative of various stages of deterioration. A possibly important distinction between these two aging methods is that the pubic bone is part of the pelvis, which is a weight-bearing part of the human skeleton, while the ribs are not weight-bearing. For each of these methods, we will look at the error in the age estimation, that is, the number of years the estimated age differs from the actual age at death. We will also investigate whether this error differs between the two methods, and also whether the error in age estimation varies with body mass index or sex.
In the weeks ahead, we'll use these and other data to illustrate the basic concepts of the science of statistics.
We will learn the fundamental techniques in order to collect, summarize, interpret, and analyze data of all types.
By the time you finish this course, you'll know how to draw sound statistical conclusions about the world around you.
So let's get learning some statistics so we can understand these data.